Hello citizens and welcome back. In today's video I want to go back and talk about the economy simulation in Star Citizen, what we think is planned and how CIG might get there. As always, if you like this video, sacrifice a like and a comment to the YouTube algorithm and subscribe for more. And don't forget to listen to the latest episode of the Comm Relay on Spotify or your favorite podcast platform. And here's a shout out to our amazing patrons for their support of the channel and the Armory. Also, if you're coming to CitizenCon this week, I'll be there either running around the event or at the ADI booth or at the Atmo Esports event on Sunday. The dynamic economy is one of the biggest missing features in Star Citizen, right next to server meshing and reputation. And I hope that CIG will talk about the economy simulation at CitizenCon this week. We haven't heard much about any work being done in a few years, so I think we're overdue for an update. And if you're a regular on the channel, you probably heard me talking about the economy simulation a few times. But if you're new here or haven't heard much about quantum and the economy, I will give you the rundown before we move on to the more technical stuff. So, Star Citizen is supposed to have a dynamic and partially player-driven economy. The economy is going to be a part of a larger simulation system called Quantum, but it is different from quantum travel. I hope that CIG will eventually change the name to make this a little less confusing. Now, you would expect that this means that only player actions impact the prices of goods and services across the verse. But players are actually not supposed to be the majority of the population of the verse. Players are set to form only about 10% of the total population. The rest are supposed to be Quanta. So what are Quanta? Essentially, they are invisible NPCs that can do various tasks around the verse. They can be miners, traders, or even pirates and security forces. Now, while these NPCs are invisible to the player, they can impact the physical verse. Their actions have an impact on the prices of goods, the discovery and exploitation of resources, and even increased pirate presence. Now, while players will never encounter a Quanta, CIG have developed a system that allows them to generate random encounters based on the actions of Quanta in the area. Let's look at an example. Let's say that there is a large resource field discovered on Daymar. Miner Quanta will flock to the location and start depleting it. The presence of miner Quanta creates a probability volume. Now, if you, the player, were to go to the same location, you have a chance of encountering an NPC miner. These mining ships that you encounter are not Quanta. They're just an NPC generated based on the probability created from the presence of a miner Quanta in the area. Now, these NPCs are generally removed right after the encounter with the player ends, but sometimes they can evolve and become more permanent. But that's a topic for another video. However, the probability volume generated by the miner Quanta attracts other Quanta. For example, service Quanta offering fuel and repair, but also pirate Quanta trying to attack and rob the miners. This increases the danger in the area, which might attract security Quanta. But as the resource field is depleted and becomes more dangerous, miner Quanta might stop going there in favor of another location. And then the overlapping probability volumes start dissolving over time. Now, while all of this is happening virtually and players are not seeing it besides the random encounters, at the same time the Quanta are bringing the ore to a refinery, which might increase the refining cost for players, and the increased intensity of combat might increase the cost of repair and fuel. On the other hand, if most or all miner Quanta in the immediate area flock to the resource field, this might increase the demand for goods elsewhere because there is no one mining there. And that's basically how the economy and quantum simulation should work in Star Citizen. There are some issues with this system, but we will get to that in a moment. More importantly, this system should be self-regulating, and it's supposed to balance out player actions, so that it's nearly impossible for players to crash the economy or do a lot of economic damage in an area. We will see how that works in practice. But I think that the general thought is that if players create an extreme, such as an extremely high demand for something or an extremely dangerous area, it will force Quanta to have an equally extreme opposite reaction. But that actually brings me to the problem Quanta would have in my previous example. Theoretically, that simulation would go from extreme to extreme based on where resources or other probability volumes are. In theory, this would result in an infinite loop of having extreme situations in one area and absolutely nothing anywhere else. Fortunately, this problem has a very easy solution that comes in two parts. First, resources in the verse are generated randomly. There are some rules on where what can be found, but the rest is random. So the chance of there being only one extremely lucrative resource area are pretty low. You are more likely to get several areas with various degrees of resource density. This forces Quanta to choose, splitting up their numbers, and their choice depends on the properties of a given Quanta. And that gets us to the second part of the solution. The verse is pretty big, so you can split the Quanta up into different starting areas, and then make the different Quanta have different willingness to travel. What does that mean? Well, let's look at the Stanton system. And let's say that every major planet has 10 minor Quanta. But let's say that only one of these is willing to travel to another major planet for mining. So that gives us 4 traveling miners and 36 local ones. So once again, let's say that a lucrative deposit is found on Daymar. The 9 local and the 1 traveling miner from Crusader will immediately go there. But only 1 traveling miner from Microtech, Hurston, and Arcorp each will make the trip. The rest will continue mining the local resources. So while this creates a hotspot, it doesn't pull all mining Quanta to one spot. This guarantees 2 things. First, the resource deposit won't be depleted too quickly, giving players a chance to get in on the action. And second, the simulation will continue everywhere else. Now, no economy is truly global, especially in the context of interstellar travel. Of course, the economies of neighboring systems will have an impact on each other, but I wouldn't expect this to be very far-reaching. But that really depends on how far will player and NPC traders want to move goods in which areas. This is also where trade policy comes in to an extent. It would make sense that within the UEE, trade is more or less free, but trading with the alien empires might be subject to tax, and the same applies to importing goods from human systems outside of the UEE. So I think what we can expect is several networks of smaller local economies linked together with small connector economies in between them. In this case, a connector economy would be a star system or several star systems on the border of 2 trade networks. So, for example, a star system that connects the UEE and the Banu Protectorate. You might be able to obtain goods from both economies there, but it might require certain reputation to access or some funds to import either way. But at the same time, I would expect CAG to introduce global dynamic events that might affect the entirety of the UEE or a smaller subsector of it, which would be very interesting. Now, at this point, some of you are probably thinking, Coder, wait, aren't you a developer? Why don't you tell us how to build this? Also, why do you know so much about the economy? Well, I actually have a minor in economy and I watched a bunch of videos on YouTube. And building this is not that easy. And also there isn't just one correct way to do this. And I'm pretty sure that whatever I come up with is much worse than what CAG do, and I will have a bunch of developers and mathematicians lynching me in the comments. But here's how I would do it. So recently I was asked by a fellow citizen to help him out with a project. He wanted to make an application that would tell you what is the best route to complete a bunch of hauling contracts that you input. It's still in development, but you can try it at hauler.thespacecoder.space. Now, the hauling route problem essentially boils down to a traveling salesman problem, meaning that you need to visit a certain number of locations using the shortest or cheapest route. There are a lot of algorithms capable of doing this, But the problem with many is that the solution complexity and the time to solve increases exponentially with the number of locations, which is problematic to say at least. Also, a small note, this and what follows are very simplified explanations, so if you're someone who works with this, you might find what I say a bit basic. But I'm trying to make this digestible for everyone. Fortunately, some smart people figured out another way to solve this problem. Several ways actually. And they all have their pros and cons and different applications. But there is a specific category that I want to talk about today. It turns out that when you repeatedly pick a random route, you will eventually find the best one. Or at least one that's pretty close to being the best. Now, developers hate random things. So, how can we make our random route a little less random? First, let's have a look at how the random route creation works. Our hauler looks at the potential places it can go and picks one at random. It then removes that destination from the list. And then it looks at the places it can go from there and picks one at random. This repeats until there are no more places to go. And the result is our random route. This assumes that the probability of picking a destination is the same for all of them, so 1 divided by the number of potential destinations. But what if it wasn't? What if we evaluated potential destinations based on some parameters? And this can really be anything you want. Maybe you want to give nearby destinations a higher rating than faraway ones. Maybe you want to prioritize completing contracts you have on board. Now, you can use this evaluation function to rate all possible destinations and then calculate the probability for each destination based on that. So you will get a number between 0 and 1 that represents the probability of that destination being picked. Doing this will start giving you more consistent results with fewer attempts. But you can do better. You could reinforce the good routes somehow. For example, every time the hauler travels from one place to another, it leaves a trail. And if the next iteration can take the same path, that potential destination will have a higher rating and a higher probability. Now, if some of that went over your head, that's okay. It's a very complicated concept and it took me a few hours to understand it enough to implement it. But what I just described is called ant colony optimization. The ants try to find food and bring it back to the colony. They leave pheromone trails to help other ants find their way. And we're doing the same thing with our hauler trying to deliver cargo. But right now you might be asking, Coder, how does this help us create the shadow economy of Star Citizen? Well, step back for a moment and think about what I just described and what we need to achieve. We need a lot of small, invisible NPCs to run around and do various tasks in the verse. That's our ants, food, and the colony. And we need the NPCs to generate probability volumes based on what they do. So that's our pheromone trail. And we need them to evaluate potential actions based on their attributes, which is the destination rating function I talked about earlier. Now, this is still a lot of information. So sit back and let me give you a few examples. Let's start with something simple, like an explorer Quanta. Let's say that it resides at Orison. Its purpose is to explore and find mineral deposits. Let's say that the parameters say it doesn't want to travel very far, so the potential destinations include Crusader and its moons. When the simulation starts, there are no trails, so that doesn't affect the selected destination. So maybe the explorer just goes to Daymar because it's the closest and there are no minerals to be found on Crusader, which eliminates it from the list. Once it arrives to Daymar, it has to pick a direction to go, and you can actually apply a similar selection process to this as well. But maybe the inputs are results of a scanner ping. And as the explorer flies around, it's leaving a trail. The trail can be positive, encouraging miners to come and mine, or negative, meaning that there are no resources to be mined. Now, you could make this more complicated by saying that the explorer has to deliver the data somewhere before it can be used. But at this point, that's pretty easy to do. So now let's try a miner Quanta. It wants to extract minerals and deliver them to a refinery. Now, when selecting a destination, it can actually use the trails left by the explorer to determine where to go. It finds the place to mine, does the mining, and then applies the same selection to find a refinery. Maybe it picks based on distance, or maybe it picks based on materials it collected. And as the miner goes around, it leaves a trail saying that the resources there were mined, making the other miners avoid the area. But these miner trails might attract pirates or service quanta, which might then in turn leave trails that attract security quanta. This then translates to probability volumes, which then create encounters for players. So we now know how we could create quanta and their behaviors. But how does this impact the economy? So far we only talked about navigation and random encounters. And that's a very good question, and the answer is surprisingly simple. Quanta may be virtual and not exist in the physical space with the players, but the resources Quanta mine, consume, and transport come from the same pool as the resources used by the players. And you can actually use this pool of resources to determine the cost of everything. How? Well, first you have to define the average starting price of everything, just to give yourself a starting point. Then, for every location that can have some kind of a commodity or service exchange, you have to define how much of which commodity it needs and how much it produces. For example, a mining outpost will need fuel, food, medical supplies, and equipment, and it will produce some selection of ores. A refinery will be buying ore and selling refined materials. The more detailed you make this, the more alive the economy is going to feel, but let's keep it simple for the example. You could also have space stations that both sell and buy fuel, because they provide small amounts of fuel as a service, but they buy fuel in bulk to satisfy that demand. All of this gives you two very important pieces of information. It tells you how much of which resource or commodity does the location want to have and how much it can store. And from this you can calculate if they're overstocked or understocked, which you can then use to figure out if they're willing to sell or buy for more or less than the average price. And if you want to be fancy, you can actually shift the average price based on the global status of the economy. I actually have a separate video explaining this process in more detail, so I will link that somewhere on the screen. But most importantly, this information serves as the input data for various quanta. Based on this, they can evaluate potential destinations and make decisions on their actions. So, for example, a miner quanta after mining is going to look for a refinery to take their ore to. So it will gather a list of all possible refineries in the area, and it will then rate them based on which one will buy their ore for most credits. And it's likely that it will select a refinery that's currently low on raw ore, meaning that they have a high demand and will pay more than average for ore shipments. And following that example, you have to create every available type of quanta. Once you have all of them, the truly difficult task begins. You have to balance all of this. The rating functions of each quanta, the starting cost of resources and services, location inventories, and the production and consumption rates, and the number of different quanta. So that's a lot of variables, and just by looking at the model, it would be very hard to tell what changes will have what effect. So what follows is going to be a lot of experimenting. But eventually you should be able to create a simulation that is more or less balanced and self-correcting. Now you might think that you actually want the simulation to create extremes here and there to give quanta and players opportunities. But actually the players will do this themselves by creating local extremes with their actions. But technically in certain locations you could create very unstable economies. This would be lawless areas or war zones or other places where nothing can be relied on. There are a few caveats with this system. First of all, you could create a simulation where a location sells resources for less money than for how much it bought the resources in the first place. So you need to figure out a way to prevent this. Second, I have no idea how this would perform on a large scale. That's a question for you software architects out there. But I would guess that Quantum can also benefit from server meshing to some degree to help manage the performance. But other than that, that's how I would do it. Shout out to Joroff for giving me the idea for the Hauler app and how to implement it, which led me to this video. Now, most of what I talked about today is pretty abstract, so if you would like to see me try to build this in Unity, let me know in the comments. It sounds like a pretty cool thing to do. And with that being said, that's all for tonight. For those of you coming to CitizenCon this week, I will see you there. Thank you for watching, fly safe, and I will see you in the verse.